All right, today we're going to go over 3.4, dividing polynomials. This is technically part 2, but we're going to call it part 3. Today we're going to look at the reason why we want to do synthetic division. And if you look at the concept, it's going to tell you pretty much everything that you need to know. We're going to be using the factor theorem, which states that an expression x minus a, so that is the factor, that is the linear function that we use to divide a polynomial. If it's a factor of a polynomial, p of x just represents a polynomial. So we're going to say that x minus a is a factor if and only if p of a is equal to 0. All right. Or in other words, if your remainder is equal to 0. Make sure that you write that down. So if your remainder is equal to 0, then x minus a is a factor. All right. So again, that is the factor theorem. So that is one of the reasons we want to use synthetic division. So let's go ahead and answer the question. How can you use the remainder and the factor theorems to determine whether the given binomial is a factor of p of x? So if you look at example 1, is asking us to first determine if the binomial is a factor. If it is a factor, I want you to write a polynomial. I want you to write the polynomial in factor form. So in essence, we're going to be using synthetic division as a different way to factor something. Okay, so that's one of the reasons we want to use synthetic division. We can actually use it for factoring. So let's go ahead and use synthetic division on problem 1. So I'm going to set up my box. You want to call it a box. Those are my terms. It looks like I am completed. There's nothing missing. So that's going to be 1, negative a, 16, negative 23, and negative 6. And it looks like I need to move my box. My binomial is going to be x minus c is equal to 0. So I'm going to solve for x, which means x is equal to 6. So my divisor is 6. All right, let's go ahead and get this started. We're going to drop the first number. So that's going to be 1. And let's go ahead and start multiplying. So 6 times 1 is equal to 6. Remember, everything that is inside, we're just going to be adding them. So negative 8 plus 6 is equal to 2. Negative 2. 6 times negative 2 is negative 12. And then 16 minus 12 is equal to 4. 4 times 6 is 24. Negative 23 plus 24 is equal to 1. And then we got 6 times 1, which is equal to 6. Negative 6 plus 6 is equal to 0. So if I follow my definition, my remainder is 0, which means that x minus 6 is a factor. So since it is a factor, I'm going to go ahead and answer the second question, which says write the polynomial in factor form. So let's go ahead and write the polynomial in factor form, which means I'm going to write that in factor form. My leading degree was 4, which means I got to go down 1. So that's going to be 1x to the power of 3 minus 2x squared plus 4x plus 1. And now I don't care about the division. I don't really care about the quotient. All it's asking me to do is to write it in factor form. So this is 1 factor plus we already know that this is another factor. So I'm going to write it in factor form. Again, I don't care about the quotient anymore. I care about the factor form. Now, the question is, and it will always be, can I go further? Is this more factorable? Well, for starters, x minus 6 is not factorable anymore. That is as far as you can go. Now, if you look at this, that is also not factorable. There's nothing we can do to figure this out or to simplify it further. So in this case, that is as much as you can go. That is as much as you can do. that would be my answer. However, I do want to say not every problem is going to be that easy. Some of them you're going to be able to continue to factor. So my advice is when you get to that point, check for greatest common factor, and I'm going to write it down so you have it there so you don't forget. But once you get to this point, check for greatest common factor, check for U substitution, check for difference of squares, and then check for sum or difference of cubes. If none of those work, then that means you're pretty much done. There's nothing else you can do. All right. So today, that is going to be your goal. I'm going to give you a binomial. First, you got to confirm that it is a factor by getting a remainder of 0. If you don't get a remainder of 0, that is not a factor and you cannot factor further. If it is a factor, you got to make sure that you factor completely, if possible. If it's not possible, then you leave it as is. Go ahead and take a minute or two, turn the page over, and I want you to answer the question, question number 2. Same thing. Determine if the binomial is a factor, and if it is a factor, factor completely. I'm going to give you 1 minute, pause the video, and then check your answer. All right, so here's for you to check your work. Notice a few things for you to notice that I am missing the degree of 4, which is why I put a placeholder. Also, my remainder is -21, which is not equal to 0, which means that x plus 3 is not a factor, which means that I can't go further. I can't try to factor further because it is not a factor, so I can't keep going. So that's it. All right. So what I want you guys to do is you're going to go ahead and work on the practice sheet. Please make sure that you complete it. The answers are on the back. I want to see your work. It should be completed by the end of the classroom. There's no reason why you should not be able to complete it. So make sure that you complete it. You're going to turn it in. Make sure that you write your name on it. And then we'll go over some questions on Monday. All right. See you guys.